7 of the 2022 AMC 10B. For how many values of the constant k will this polynomial have two distinct integer roots? So what this means by the roots are these over here. If we expand, okay, so we would have this form when we expand the equation. And the roots are referring to these over here, but these are dependent on these. So in reality, we could just care about these, a and b, because to get k, because k is basically just the sum of a and b. And it's also important to note that a and b have to, the product of a and b has to be 36. So that means a and b are factors of 36. So let us list the factors of 36 down here. We have 1, 36, 2, 18, 3, and 12, 4, 9, 6, and 6. But notice right here they say distinct roots, which means they can't be the same. So we can rule out, so 6 and 6 will not help us here because they're the same. Because if this was 6 and this was 6, then this would be negative 6 and this would be negative 6, so they would be the same. The roots would be the same. And when we have a and b is 1 and 36, then k would be 37, 2 and 18. The sum of that would give us 20, and so on and so forth. That's not a 1. So on and so forth. But it's also important to think about the negative factors of 36. So we could have negative 1 and negative 36, which would give us negative 37 for k. That would be 2 and negative 18, negative 20, so on and so forth. So for each of these possibilities over here, for each of these possibilities, we can just multiply by 2. So since there's 1, 2, 3, 4 possibilities, times 2, that's 8. So there are 8 possible values for k, both positive and negative. And sure enough, that is an answer choice. Answer choice B is 8.